the difference between average rate of change and slope, even though we use those words interchangeably, is that I will use average rate of change when we're talking about graphs that aren't straight lines. So kind of graphs that we were looking at yesterday when we were doing domain and range, they're not perfect graphs. And so that's a case where we would call it average rate of change instead of slope. Okay? But for this case, or for the sake of the meaning of the word, slope and average rate of change are the exact same thing. Okay, so example 1 says, find the slope of the following line using 2 different methods. So we know when we get slope, we can just count and do rise over run. So if we draw our little triangle box here, it looks like 1, 2, 3, 4 there. Okay, now is that slope positive or negative?
Negative.
Negative, it's going down from left to right. So based on rise over run, we would have a slope of negative 4 over 5. Okay, then we can do it using the 2 points. It's kind of hard for me to see those. Negative 2, 3, and is it 3, negative 1?
Yeah.
Okay, so there's our 2 points. Okay, some of you did stack and subtract. I'm going to go ahead and do my formula. y2 minus y1 over x2 minus x1. What happens there on the bottom? 3 minus a negative 2.
Change it to.
Yep, addition. So I should have negative 4 over 5. Okay, obviously those should be the same thing because we're dealing with the same graph. Okay, is that a good reminder on slope? Be okay on that?
Yeah.
All right, so for a line, it is unique in the fact that slope is constant. So no matter where we find the slope on a line, it will be the exact same slope. Okay? So whatever 2 points you choose on a straight line, it's going to be the same slope. What happens though when the rate of change of a function is not always the same? Well, then I have to ask you, give me the average rate of change between these 2 x values. You'll see that a lot. Okay, so let's look at example 2, and you'll kind of see what I'm talking about. So we have a family that is taking a trip on the beach. They leave, or to the beach, I should say. They leave their house at 6 a.m. and arrive to the beach at 2 p.m. So you're going to see down here time. We start at 6, we end at 2 p.m. Use the idea of rise over run here to help you. Okay, so part A. The graph shows a change in speed by 8 a.m. You'll notice from 6 to 8, would you say that that's constant?
Yeah.
They're traveling at the same speed. Okay. So then at 8 a.m., they change speeds. It says, what is the average rate of change in miles per hour between 6 a.m. and 8 a.m.? So what we're trying to find is, we're trying to find the average rate of change between 6 and 8. So if we look here, this goes over how many? 2. Okay. Now you may say 4, but it's really from 6 to 8. So that's a change of 2 hours. Okay. And then let's go ahead and label that. That's a good idea. Go ahead and label that 2 hours. Okay. And then how many do we go up? 150?
Yes.
Yeah. Right. Because we go up 50. If you look here, it goes from 0 to 150, and that would be miles. Okay, so if we write this, that would be 150 miles every 2 hours. Let's stay focused. We should be taking notes. Eyes on the board. Now, if I did 150 for 2, what would I get? So is it fair to say that they were traveling at a speed of 75 miles per hour?
Yes.
Yeah. Okay, so that's 1 mile, or 1 hour for every 75 miles. All right, what is the average rate of change in miles per hour between 12 p.m. and 2 p.m.? So 12 p.m. and 2 p.m. So let's go ahead and look. So 12 here, and 2. So we're going to go ahead and do our rise over run. How many do I go here?
2.
That's 2.
Like
And
50.
here I go 50. Okay, so that's 50 what?
25.
Miles.
50 miles every 2 hours. So that would be 25 miles per hour. So obviously they were going slower there. If you look at their trip, think about it. When you initially start driving on the highway, right, you're going pretty fast. When you start to get to a city and stuff like that, you gotta slow down, you gotta take turns and stuff like that. So that's what's going on here. Part C, what is the average rate of change in miles per hour between 11 a.m. and 12 p.m.? So 11, right here, and 12. Ooh, interesting question. Okay, what is it?
1.
0 miles.
Okay, think about rise. Our rise is 0, correct?
Yeah.
Okay, our run is 1. So that's 0 miles per hour, because 0 divided by any number is just 0. So, what's going on here? They're not moving. Why do you think they're not moving? Look at the time. 11 to 12. Probably lunch. Okay, lunch and gas maybe? They stopped for lunch and gas? Alright, there you go. They stopped for lunch, slash gas, slash bathroom, whatever you want to put there. Okay? As long as it makes sense in the context of the problem, I'm not going to argue it. If you told me that they stopped for dinner, I'd be like, probably not. Okay? But, any of those would be feasible. Alright, part D. What was the average rate of change in miles per hour for the entire trip? Now, this is an interesting question. Stay focused, please. Okay? This is an interesting question because is it a constant rate of change from start to finish? No. But they're saying, what is the average rate of change in miles per hour? So we're going to choose this point. Let's go ahead and do our rise over our run. Go to this point. Could you do this using slope formula?
Yes.
Yeah. You could. Go ahead, think. None of this counts. All right, so we have 2, 4, 6, a total of 8 hours for their trip. And then a total of how many miles? 350 miles. All right, so if we do that, put it right up here. 350 miles divided by 8 hours. Who has their calculator out? 350 divided by 8. Do it for me. It's not going to be nice.
43.77.
Okay, so they went, their average speed was 43 and 3/4 miles per hour. Now, sometimes they went faster, sometimes they went slower, like we found in A and C, or A and B. But that's their average. Are you with me on average versus slope? Okay, all right, good. Between what hours do you think the family is traveling the fastest?
6 to 8, 10 to 11.
6 to 8. Okay, so 6 to 8 was what, 75? Okay, 10 to 11 is
75 over 1.
Is it 75? No.
That's 1 hour.
Oh, no, that is 75. Oh, that's 1. Yep, so they are the same. Okay, that's just quick math. So you could say in part E, from hours 6 to 8 and from hours 10 to 11, they are traveling the fastest. What was it, 10 to 11? Okay, how can you tell? What did you initially do when you looked at the graph to tell where they were? Yeah. Which one's the steepest line? All right. Did the family drive the same speed throughout their entire trip?
No.
No.
No. Okay. And it says in mathematical language, was the rate of change constant? No, it was not, right? It was changing. Okay, so you could change changing each hour. It was periodically changing, however you want to say that. It's fine. But just so you know, it's not constant. Okay, so if we find the average rate of change, we can do it using slope formula. This formula right here is literally the exact same thing as slope formula. It's just different letters. Okay, this is saying y2 minus y1, x2 minus x1. That's all it says. I don't want you to get overwhelmed by anything new. It's the exact same thing. All right. So here's what I want you to do. When you get something like this, you need to write coordinate points. So what this is saying is the function is given below. Find the average rate of change over the intervals. Okay? So I have given you the x values. So go ahead and write the x values of your coordinate points. Okay, when x is negative 6, 1, 2, 3, 4, 5. Here's negative 6. Y is what?
1.
1. So that 1 is going to go with the negative 6. We're going to complete that coordinate point. And then when x is negative 2, y is negative 3. Okay, now we're going to use slope formula to find the actual average rate of change there. So my y is on top, negative 3 minus 1. On the bottom, negative 2 minus negative 6. What's going to happen there on the bottom? Addition. All right, what's negative 4 divided by 4? Negative 1. So our average rate of change from where x is negative 6 to where x is negative 2 is a change of negative 1.
Wait, isn't there the 3 negatives? So it would still be negative. Two of them will cancel each other out, but they'd be.
So we did negative 2 minus a negative 6. So it's 2 negatives. Yeah, negative 2 plus 6.
Oh,
So yeah, a negative 2 plus 6. All right, part B, same idea. We already found the y value that corresponds with negative 2, right? It's negative 3. We found that in the previous question. Okay, when x is 2, what's y?
1.
Negative 1. Okay, I want you to go ahead and do the slope on that. Get 1/2? Okay, if you didn't, check your work up here. Okay, sometimes those negatives can throw you off. Okay, right here you ended up adding 3, and on the bottom you ended up adding 2 because you had double negatives going on there. Okay, so we have the x values of 2 and 4. We're going to find the average rate of change between 2 and 4. So when x is 2, y is negative 1. When x is 4, y is 3. Go ahead and do your slope. can check your work when you get that one done. Okay, try part D all on your own. Go ahead, write the points and do that slope. Okay, you should end up with 2 over 10, which is technically reduced to 1/5. 1/5 for that one. Are you okay on that? Yeah. Okay, questions before we move on? Or must have done Okay. All right, this is an OFT question. You may have seen this on the practice yesterday, I think. So if you look here, we have a function. Now, do we have a table yet? How do we get a table? What's the easiest way to get a table? Desmos. Okay, so I'm going to go to Desmos. You don't need to go to Desmos. Let me just put it in. We can do it together here. Okay, you're going to type in your function. Somebody read me that function, please.
5t
Okay.
equals negative 2 to the second
Okay.
minus 14t minus 4.
Minus 40. Okay, so you don't know this. Desmos does not like any variables other than x or y. So I had to change everything into x and y. Okay, that shouldn't hopefully be too hard for you. Whatever is usually where x is at, just change it to x. Okay, now I'm going to press my wheel up here. And then my table, and I'm going to get my table out. Okay, I think we only need positive values. Is that right?
Yes.
Okay. So we need to get
4 to the 10.
Okay, so 4 corresponds to negative 112. 5 corresponds to negative 135. 6 corresponds to negative 160. 7 corresponds to negative 187. 8 corresponds to negative 216. 9 is negative 247. And 10 is negative 280. Who isn't that fun?
Yeah.
Okay, bear with me while I write these in here. Okay, now, the reason I'm showing you this is because there's a lot of different ways that you can do this. Okay, there's a lot of ways this problem can be done. Yeah, I don't know why. I didn't make this slide, and I don't know why. We're going to figure it out together. Okay. So if you look at the graph that we're given, not really easy to graph based. I don't know why they did that. But to me, I wouldn't even use the graph, to be honest with you. I think the graph is going to be way more confusing and you're gonna spend too much time trying to draw it. So let's just like forget about the graph. Okay. All right. So we're gonna select all these statements that are true about the graphs of y of t for where x is between 6 and 8. Okay. So the first one says the value of y increases when x is between 6 and 7. Okay. Here's what I would do. I would go back to the actual visual graph that you can get, okay, and look at 6 to 7. Okay, there is something. I put something in wrong. There is something wrong. Guys, look at my function. Is that function right? Are you? Was it negative at the beginning? Oh, it's plus 14. Aha! Great, now your numbers are off. Okay, now I know why they did that. Erase those numbers over.
She said
No, it looked like it filled fractions on our.
They probably didn't copy well.
No,
That's alright. No harm done. Leave me alone. No harm done. We have time. We're good.
what is that?
yeah, drop some of
Okay, let's write these in. So, great. Why is this not?
the bottom ones, and you just go up.
Oh my god, Cody's bleeding out again.
There we go. All right, so 10 corresponds to 0, 5. All right, that's what you should have. Now we can graph it. It makes so much sense.
200.
Makes so much sense now.
So much better.
All right, 4, 0, 5, 5, 6, 8, 7, 8. Oh, this one. Okay, so now I think this is going to be a little bit easier to see. The value of y increases from 6 to 7. So look at from the values of 6 to 7. Okay, right here. 6 to 7. Is that increasing? Yes. Check it off. Okay. The value of y increases from 7 to 8. So 7 to 8 is right here. Is that increasing? That's decreasing, right? So we're not going to check that one. The average rate of change from 6 to 8 is 0. Now, that one you might not be able to pick out based on the graph. So let's go ahead and write the points down. Okay, so we know we want x to be 6 and 8. Okay, so when x is 6, y is 8. When x is 8, 8 is 8. Okay, so if I did the slope formula, I would have 8 minus 8 on top, 8 minus 6 on the bottom. Is it 0? Yes. Okay, I think it's a good idea to check it with the formula. That way you know, beyond a shadow of a doubt, that it for sure is 0. Okay, now, this next one is frequently missed. The value of y is constant between 6 and 8. Is it constant?
No.
Okay, think back to a straight line. A straight line has a constant slope, meaning it's never changing. Is the slope the same from 6 to 7 and from 7 to 8?
No.
No, it's not. Because one of them would be positive, one of them would be negative. So while it's 0 from 6 to 8, that does not mean that it's constant. Okay, constant means it continues the same way. We're not going to check that one. Last one. The average rate of change from 6 to 7 is the same from 7 to 8.
Yes.
You just told me the answer, right? Is it the same from 6 to 7 and 7 to 8?
No.
No, right? Because one of them is positive, one of them is negative. So only these two will be the ones to check. I believe the rest is practice. So go ahead and get started on the practice.